just a tad, but we'll see. As you get to the end of I-4, they start to ask about some specific things, and they ask about, hey, are any of these discontinuities what we call removable? Now, to show you kind of what removable means, I want to use the function x squared minus 4 divided by x plus 2. In the next few seconds or so, we're going to really look at, there are two types of discontinuities, and you've seen them a little bit already, where you've got the one with a solid dot and an open dot, and so on, or some other different things, and then you might have lines that go one way and lines that go the other way. They are what we call infinite ones, which come from the fractions. Those are the asymptote kind of ones. You don't see the dashed lines on here, but that's where they're coming from, are the asymptotes. We're going to call those infinite ones, and they come from fractions that have the division by 0. Those domain issues that we had yesterday, or the day before, that's where these infinite ones are coming from. The other ones we're going to call jumpers. They come from piecewise functions. We'll get to those in I6 here in a minute. But that's where this kind of stuff possibly might come into play with these piecewise ones. Now, specifically, the infinite ones. Back to the x squared minus 4 thing. If I look at this, at -2, this thing's going to have some issues. It's going to have a vertical asymptote. It's going to be one of the places things are going to be discontinuous, okay? So our first answer to this whole thing would be it's not continuous at x equals -2, kind of like we did on the green sheet. But if you go back and look at the original function, I can maybe try and make that discontinuity go away. Can I remove it from the equation? And the way I do that is I'm going to factor the top, and then I could actually remove that one. Oops, wrong one, canceled it. Remove the x plus 2 from the bottom and the top by canceling the same thing, and I'm left with x minus 2. So I just removed it, and what we'll actually do is actually circle that to remove it, and the reason we circle it is when it's a removable discontinuity, it's going to look just like that. There's going to be an open dot with 2 lines coming out of it. Okay? Open dot with 2 lines coming out of it. So in this case, I actually have -6 is an issue for my 1 is an issue, and 9 is an issue. And they're going to ask how many of those are removable. Well, there's one there that's got 2 lines coming out of it, one there that's got 2 lines coming out of it, and another one there. So all 3 of those are actually removable, and then we put that in there for what we need. 3 and go. Okay. So that's how you finish up I-4. And you can see here, this is kind of one of those infinite ones. That is not a removable one because that only has 1 line coming out of it. Okay? It only has 1 line. Only have 1 line coming out of it. The only removable one in this graph is really that one right there. Okay? Now, just since I'm here talking, the next one you run into is I6. I6 has to do with these piecewise ones, which we call jumper ones, and has some algebra coming up. There's not a lot of graphs on this one. With this, there's a couple little tricks, so bear with me. I'm going to cover them so I can get them all out of the way on this one shot. With continuous functions, it doesn't matter what's going on. They're going to say, hey, is this continuous at x equals -9? 99.9% of the time, it's the same number that's right here. Remember, this determines what level you're on. For what we're going to worry about, we're not really going to pay any attention to this. We want to know what's going on one side of -9 and the other side of -9 with these two things. So the way we decide is this continuous is to take whatever number that is and plug it in there. So 9 plus 1 is 10. And I also plug it in the other level. 4 times 9 plus 16 is 36 plus 6 or 52? Yeah. 52. Are they the same? No. So this is a no. If they're not the same, it's not continuous because one's up here and one's down there. If they are the same, it is continuous. Right? All right. Now I got one more thing I want to show you because it shows up. Some of you are probably getting there later on. Give me about 85, I think it is. Some of them might have 3. There's one that's got 3, but no matter what you're plugging in, x equals 4, so I'm plugging in 4 there, 4 there, and 4 there and see what happens. All 3 of them have to be equal. Please give me the one I want. No, we did not. Did earlier. Come on, give me the one I want. There we go, got it. Here's one of these that's kind of involves the little canceling we had before that I want to cover because you're going to run into it. And you might, I'm going to save you a missing one if I can. This one here, when you try and plug in the 7, I try and plug in the 7, what happens? I need 0 on the bottom, don't I? Can't do that. So how do I compare? Well, what did we do over there? We can factor x squared minus 49, can't we? That's going to be x plus 7 times x minus 7, so that allows me to remove those x minus 7s. So really on the top I just have x plus 7. So now I can plug the 7 in, and that's just 7 plus 7, which is 14. Plug the 7 in there, get 13, and so that's a no. That help? So you run into that possibly once in a while, so be careful on that. All right. Let me shut up for a little bit, then we'll get to the book, and we'll go through the book at the end. And that'll give us all we need for the weekend.